Hello, everybody. Good morning. How are you today? Today's assignment, number 14, is all about the rules of logarithms. So exponents had rules, and since logarithms are just exponents, they have rules of their own. There are 3 rules we're going to go over today, and we are going to hammer those down throughout the week and make sure you understand them completely. So let's get started. So here are your 3 rules of logarithms. Since logarithms are exponents, you're going to see a bunch of similarity between our exponent rules and our log rules. So the first log rule is that if we have the log with the base of x of a times b, so one log expression where this is called the argument, what's in the argument is being multiplied, then what we can do is break it apart and add them. It's the same thing as if we are multiplying exponential expressions with a common base. You combine them to one exponential expression and add the exponents. So here's the link. We're multiplying, and with exponents, multiplication means we're adding. So we can break this up into the log base x of a plus the log base x of b. So that's the first rule logarithm. Log base x of a times b is equal to the log base x of a plus the log base x of b. Similarly, if we are dividing in a log expression, so we have the log base x of a divided by b, well, what happens when you're dividing with exponents? You subtract the exponents. So it's the same thing here. We are subtracting the logs, again, because logs are exponents. So this becomes the log base x of a minus the log base x of b, because we're dividing in here, which means it's going to become a minus outside over there. And then our other one is we have the log base x of a to the power of b. Well, what happens when we have an exponent raised to an exponent? We multiply them. So for this one, our exponent of b is going to kick out to the front and become b times, because that's the exponent, b times the log base x of a. There's our product rule. Or our power rule, excuse me. We have the product rule up top, because we're multiplying, the quotient rule in the middle, because we're dividing, and our power rule at the bottom. That's it. Those are our 3 rules of logarithms. Now, let's go and apply them. So here's our first rule, right? It's the power rule. The product rule. We've got log base x of a times b equals log base x of a plus the log base x of b. So if you're told to expand the log base b of x times y times z, x, y, z is x times y times z. Well, using this rule, this is just going to become the log base b, that doesn't change, of x plus the log base b of y plus the log base b of z. So when you are multiplying inside the argument, you're going to give each of these terms its own log with the base of b and just add them together. This means, right, you can even put those in parentheses because it's all together. That is what's happening here. Log base b of x plus the log base b of y plus the log base b of z. All right, it works in the other direction as well. So this is still using the same product rule, but now we want to express this as a single log expression. We've got the log base 2 of a plus the log base 2 of b. Since we are adding the logs and they have common bases, this just becomes the log, the base is 2, and since we're adding, what's going to happen to the a and the b, right? We're adding the a and the b here. They become multiplying in the same logarithmic expression. So it's going to become the log base 2 of a times b, or just ab. So that's how it works in both ways. So here's an example using our quotient rule, is if we are told to expand the log base b of y divided by z, well, we know it's going to keep the log base b of y, and since we're dividing here, we're going to subtract the log base b of z. So it's just going to become the log base b of y minus the log base b of z. What about this next one? This says to expand the log base b of xy divided by z. So first, let's examine what's happening here. We have the log base b of x times y, and both of those are being divided by z. So we're going to have to use two different rules here, okay? Whoops. The first one is we've got, well, the log base b of x. Now that says times y. So what does that mean if we're multiplying? That means plus the log base b of y. Now we know that we are dividing both of those by that z. So we're going to put these two in parentheses because they're kind of like grouped together up top. And then we're going to subtract the log base b of z. All right? You don't have to do parentheses in this particular example, but I always say put it in because there are some examples where you need them. Right? The order of operations would say as we're adding and subtracting, it just goes in order from left to right. So this would be correct without the parentheses anyway. But we are both multiplying and dividing. So we have to add log base b of x plus log base b of y because we have x times y. Then we have to subtract the log base b of z because we're dividing by z there. So this is using both rules. And then similarly, we go in the other direction, the log base 2 of a minus the log base 2 of b. We're going to write this as a single log expression. This is just the log base 2, since they're both log base 2. And we have a minus b, which is just a divided by b. So it's the log base 2 of a divided by b. And then finally, here's applications of the power rule, which is the log base x of a to the power of b is equal to b times the log of x, the log base x of a. Kind of looks like blog. But in any case, if we have to expand the log base a of x squared, well, we're just going to take, let me take this, sorry. We're going to take this exponent of 2 and just kick it out to the front. And it's just going to become 2 times the log base a of x. That's it. That's the power rule. We take that exponent of that x, we're going to kick it out to become the coefficient, and it becomes 2 times the log base a of x. Now let's look at this next one, which we have to expand the log base b of x squared times y. So be careful here. Think, what's being raised to that power of 2? The x, the y, both? Well, the answer is just the x is being raised to that power. So we have to make sure that only that x gets that coefficient of 2. So the first thing I'm going to do is break this apart using the product rule. So we have x squared times y. That's just going to become the log base b of x squared plus the log base b of y. All we did was use our first rule that we went over, our product rule, and said, all right, x squared times y, we're going to break that up into the log base b of x squared plus the log base b of y. Now we have to deal with this power rule and this exponent of 2, which is going to be kicked out into the front, and it's going to become 2 log base b of x plus the log base b of y. So notice, only that log base b of x expression is being multiplied by that 2. That means that only the x is being raised to the power of 2. If I wrote it like this, with the log base b of x plus the log base b of y, if I wrote in parentheses, if I wrote it like that, well, then that's a different story. This would become the log base b of xy, that whole thing being squared. So you see the difference between what I wrote in red, which is this expression, as opposed to how it was without the parentheses when it was equal to what's on top. So the correct answer for this one is no parentheses. It's just 2 log base b of x plus the log base b of y. Next up, we have the log base b of x squared y to the third over z to the fourth. At this time, I would like you to pause the video, try to see if you can work this problem out, and then once you're done, hit play and we'll go over it. So please pause your video now and try this problem. All right, hopefully you did it and you're not just letting it go, because that's how you learn, is by trying. log base b of x squared y cubed over z to the fourth. I'm going to break this up into using our product and quotient rules first. So this would become the log base b of, well, x squared plus y, getting ahead of myself, plus log base b of y cubed. You want to put that in parentheses, and then we're subtracting log base b of z to the fourth power. So that's our first step. We used our product rule to break up our x squared times y cubed in the top. That became this over here. And then since we're dividing by z to the fourth, we use the quotient rule to subtract the log base b of z to the fourth. Now from here, we use our power rule, and this 2 is going to kick out in front of that log base b of x. This 3 is going to kick out in front of that log base b of y. And this 4 is going to kick out in front of that log base b of z. So we are going to get a final answer of 2 log base b of x plus 3 log base b of y minus 4 log base b of z. And that is your final answer. You don't need the parentheses in this particular problem again, because our PEMDAS rules of operation, order of operations would work out going from left to right. So that is your answer for the last one. Very good. All right, last example we'll go through today is what if I had the log of the fourth root of a times b. Now you're going to see on some or all, let me just on all of the problems you have on your homework assignment is you're going to see no bases written. We're going to get into what that means a little bit later on, but for now, just know that that means that there's a base of 10 that's understood to be there. The same way there's an exponent of 1, a coefficient of 1, a denominator of 1. In a radical, if there's no index there, it's really an index of 2. So right here, where there's a base that's missing, it's really a base of 10, but that's not super important for what we're doing right now. So basically for this problem and for your homework, you could leave the base off. So we have the log of the fourth root of AB. So how would we expand this? All right? We have a radical. Ignore the log for a second. What does a radical mean? A radical means we have an exponent that's a fraction. So this is going to be equal to the log of a times b. Now notice, I have to put that a times b in parentheses because they're both under the radical here. And that's being raised to what exponent? 1 over 4. So that equals the log of a times b to the 1/4 power. Now we can expand this, okay? On the previous problems, we broke it up, then did the power rule. However, if you notice in this problem, they're both being raised to the power of 1 over 4. So we need to deal with that exponent before we can break it up. So we're going to have to take this exponent and kick it out in front first. And that becomes 1 over 4 times the log of AB, which hopefully you will have no problem doing at this point. And we'll say, all right, that's 1 over 4 times the log of A plus the log of B. Another way we can write that is just the log of A plus the log of B all over 4, because they were all being multiplied by 1 over 4. So hopefully you have no issues with that. So hopefully that wasn't a problem for you. It is currently raining and very windy out. I'm recording this on Monday. So I figured this was a pretty topical ending slide. In any case, those are your rules of logarithms. That's how you use them. This is what we're going to focus on for this entire week. Okay, obviously today's assignment will be a little bit easier than the assignment we're going to give on Thursday, but hopefully you have no problems with it. If you have any issues, as always, email myself, Mr. Zorling, or Mr. Fallett, or Professor Tito, and one of us will get back to you. I hope you're all staying healthy, staying safe, and I hope everyone in your family is also healthy and you have no problems. Again, Keep doing your work. We don't know what's happening with grades just yet, so you can stop emailing me. And that's it. Have a good one, guys.